In this video, we present 4 interaction techniques for manipulating screen objects on a multi-touch interface. Here, Microsoft Surface. The presented techniques allow the same multi-finger manipulations than current multi-touch products. Users can rotate, scale, and translate objects with several fingers. Unlike current multi-touch mechanisms, our techniques allow users to restrict the manipulation to a subset of the possible manipulations. Multi-finger interactions on tabletop systems allow users to move, rotate, and scale objects, all at the same time. We will use the term unrestricted manipulation for this component. Manipulating objects in this way resembles the way in which we manipulate real objects and could also improve the speed of complex manipulations. On the flip side, this all-at-once interaction makes it difficult to perform only one manipulation. For example, an object that is already properly oriented and needs to be scaled is difficult to scale without also affecting its orientation. We have explored 4 different approaches. Apted and colleagues suggested the use of handle regions to manipulate objects in a tabletop system. Their objects can be translated by touching on the center or rotated and scaled by touching in the corners. We adapted this technique to allow independent manipulation of rotation and scaling. The magnitude filtering technique filters each degree of freedom so that manipulations below a certain threshold are ignored. The motor space is enlarged around the orientation, size, and position of the object when it was first touched. A continuous transfer function between input and output prevents an excessive separation of the fingers and the object. With the frame-to-frame gesture matching technique, the user indicates the system the desired operation through a quick gesture. Unless another fast gesture occurs, the object can only be manipulated in the current mode. Finally, the first touch gesture matching technique tries to predict which simplified operation the user is trying to perform. The object jumps from one position to another according to the prediction of a battery of gesture models. We compared the techniques in a controlled experiment. We found that first touch gesture matching, handles, and magnitude filtering help users to avoid undesired operations. We also found that handles slows down the process significantly.